Today we're going to take a look at parabolas and using something what's called the locus definition of a parabola and then a formula for a parabola. So I will be teaching this a little bit different than maybe Kirk will be teaching us. If you would like to see a different version, more using the locus definition as well as the distance formula, use the QR code at the top to go to Kirk's videos. I kind of like to look at this in terms of a formula. I know it's one more thing to memorize. However, I feel like this is a little bit easier and maybe a little bit quicker to get to the actual answer that we're looking for. So first off, the locus. Locus is just a Latin word meaning location. So our definition of a parabola is based off of the location. So it says a parabola is the collection of all points equidistant from a fixed point known as its focus and a fixed line known as its directrix. So they're equally spaced from these two things, these two objects, the focus and the directrix. And if I take a look at all of the points on the parabola, it will always be equally distant. Any point on the parabola will always be equally distant from the focus and the directrix. Now, a formula that will give you that equation for a parabola is given below. So the things that you need to know is HK, those two letters. That is going to be your turning point or the vertex of the parabola that we have found in the past. And then the letter P, that's new, that's the focal length. So what we need to know, that's going to be the distance from either the focus to the vertex or the distance from the directrix to the vertex. We're going to take a look at this graphically so we can see where all of this comes together. But those are the vocab words that we need to be aware of. Okay, so the parabola that we have to the right has that equation, and it's graphed, and it says the selected points are shown. So for this parabola, the focus is at that location 0, 2, and its directrix is the x-axis. So by that definition, any point on the parabola should be equally distant from both the focus and the directrix. And I can see easily that turning point, that's the case. From the focus and the directrix, it's 1 unit away. Okay, if I were to take a look at this point here, this point is 2 units away from the focus and also 2 units away from the directrix. Okay, now when we get to other points, it may be a little bit harder to calculate that distance from here to the focus, but I could use the distance formula, and I could see that it should be the same distance from here to the directrix, which is a distance of 1, 2, 3, 4, 5. Okay, and if we calculated this, we would see how far that is located. So it says, how far is the turning point? Our turning point, or another way that we could say this, is the vertex. How far is the turning point or the vertex, which is 0, 1, from both the focus and the directrix? Well, from the focus, here's my turning point or my vertex. I can see that's a distance of 1. From the directrix, I can see that that is a distance of 1. So I can say, from both the focus and the directrix, it's 1 unit away. This 1 that we have found is equal to that P in the formula. That's going to be called your focal length. Okay. And so then keep in mind, the other thing that we know is that our vertex is at that location 0, 1. So the formula that we have up above, we're actually going to use that to prove that we can get this equation. Okay, so we're going to write down that formula just so we have this here. So we have x minus h squared is equal to 4p and then y minus k in parentheses. Okay, so we're going to plug in what we know. So keep in mind that vertex, that turning point, that's 0, 1. So I have x minus 0 squared is equal to 4 times p. P is 1. Okay. These two numbers are all being multiplied by y minus k, and our k value is 1, again, from the vertex. So we're going to simplify this. So x minus 0 squared, that's just x squared. Over here, we have 4 times y minus 1. Now, we could solve this 2 different ways. I could either distribute the 4. So I have 4y minus 4. Now, what we're trying to do is get y by itself. So I would want to add over the 4. So I have x squared plus 4 is equal to 4y. And then to get y by itself, I have to divide everything through by 4. So when I say everything, each of these terms has to be divided. Okay, and if we simplify, so this simplifies down to y. This here, my first term, I could rewrite that as 1/4 x squared. Those two things are equivalent values. And over here, 4 divided by 4 is 1. So you can see we have just proven that, yes, that is the same exact formula. Now, a different way that we could solve this to get the same answer is if I go back to this step here, you could actually divide through by 4 first. Some people prefer to do that. Okay, so again, we have that 1/4 x squared is equal to y minus 1. And then the last thing that we would do is add over that 1. And again, we get that same equation that we had up above, just two different ways to solve it. It's up to you, just a preference. Okay, so let's try another one. So we have a parabola whose focus is the point 0, 7, and whose directrix is the line y equals 3. So first thing that we're going to do is we're going to sketch a diagram of this parabola and identify its turning point and focal length. So they've given us the directrix of y equals 3. So that's a horizontal line at 3. Okay, they've also given us the focus, which is at 0, 7. So there's 3, 4, 5, 6, 7. So at this point here, I'm going to label that F for focus, and I know that that's at the coordinate 0, 7. Okay, so something to keep in mind, your parabola will always open up away from the directrix. It should never intersect it. Okay, so that means I know that my parabola has to be pointing up. And then number 2, when I'm trying to find the vertex, keep in mind, is going to be the same distance away from the focus as it is from the directrix. So if I'm looking at this total distance that I have here right now between these two, I have a distance of 1, 2, 3, 4. Okay, so that means my vertex has to be located 2 units away from each. So there's 2 units, there's 2 units. That means this is my vertex, and my vertex is going to be at the location 0, 5. Okay, so remember what we said. When you draw your parabola, it should never intersect the directrix, and it should always surround the focus. So that's the basic idea. It's not pointing down to intersect the directrix, and the focus is in between the arms of the parabola. So that's our basic parabola for right now. So if we were to answer some of these things, I could say the vertex, which we have labeled, the vertex is at the point 0, 5, and then our focal length, remember that p-value, your focal length is 2. That's that distance between the focus and the vertex. Okay, so we have everything we need to determine the equation of the parabola. Okay, so we're going to plug this in. So we have x minus h, which is 0 squared, is equal to 4p, so 4 times 2, and then y minus k, our k value is 5. Okay, and again, we want to get y by itself. That's always going to be our goal. We're going to start here and get y by itself. So we simplify, have x squared is equal to 8 times y minus 5. Now remember, you have 2 choices on how you could simplify. So maybe let's do this one by dividing everything through by 8. Okay, so that gets us 1/8 x squared is equal to y minus 5. Remember, you could also distribute that 8 through. Now we want to get y by itself, so I'm going to add 5 to each side. I get 1/8 x squared plus 5 is equal to y. And that would be the equation for your parabola. Okay. And lastly, another example. We're going to determine the equation of the parabola whose focus is the point 4, -1, and whose directrix is the horizontal line y equals 3. So again, first we're going to draw a diagram that shows the parabola. We're going to find the vertex, figure out the focal length, and then we're going to use that formula to derive its equation. Okay, so first thing I'm going to graph is the line y equals 3. So if I'm looking at y equals 3, again, that's that horizontal line. That's your directrix. The focus is the point 4, -1. So over 4, I'm going to go down 1, and this, I can tell you that's going to be our focus. I'm going to give us this coordinate here so maybe I can see what's going on. Okay, so we need to find the focal length. All right, well, the focal length, again, we want to figure out the distance between the focus and the directrix. So if I were to count up 1, 2, 3, 4, I can tell you this total distance here is 4, which means my vertex should be equally spaced between those, or 2 units away. So I would go up 1, 2. This point here would be my focus. I'm sorry, my vertex. And the vertex then is going to have the coordinate over 4 up 1. So I'm going to label this over here. This is going to be 4, 1. And if I were to take a look at the distance then between the vertex and the directrix, I can see it has a focal length of 2. But now here's something that we have to be careful with. So it does have a focal length of 2, but notice the direction. If we were to just draw this out, the direction that our graph would have to open. So I can't draw it to intersect the directrix. It has to go away from the directrix. So if here is my vertex, and again, it has to surround the focus, I know that this has to be pointing down. So that focal length, while yes, it's a distance of 2, we want to make sure we're saying that focal length is a -2. That's your p-value. Okay. The other way that you could do this is if you didn't say it was a -2, I just think it's a good habit to get into that. I know you can't have a negative distance, but that negative tells you the direction. That when you write your formula, okay, you have to make sure that then the p-value is negative because it's pointing down. So the equation that we have, x minus h squared is equal to 4p y minus k. So again, your focal length really and truly is 2. That is telling you it's opening up, pointing down. Okay, so if we plug this in, so we're going to have x minus 4 squared is equal to, okay, so watch your signs. I have to say 4 times -2. That's where you'd have to remember to put the negative in if you didn't tell me that up here. And then I'd have y minus k. Okay, so we simplify. And now I'm just going to leave this as x minus 4. I don't have to expand that out. I lied. We do. I'm kidding. We do have to expand that out. We want to expand that out just so that we can solve and get y by itself by an actual parabola equation. There are times where they don't. Usually you do want to expand that out. Okay, so let's go back. We're going to simplify this. Remember, if this is p squared, this is x minus 4 times x minus 4. So we have to do a little foiling, or you can use the box method. Okay, so our outside terms would give me x squared, right? First terms, I'm sorry. Outside terms gets me -4x. Inside terms gets me -4x. So if I combine those, that's a total of -8x. And then my last terms would give me a positive 16. Over here, I have a -8 times y minus 1. Okay, so again, we're trying to get y by itself. Up to you how you want to do this. I'm going to divide through everything by a -8, but now keep in mind, every term over here is divided by a -8, and we have to watch our signs when simplifying. Okay, so this would give me a -1/8 x squared. I have a negative divided by a negative, so that's a positive. 8 divided by 8 is 1x. Next term, I have a positive divided by a negative, which is a negative. 16 over 8, which is 2. And now over here, I have y minus 1. And then to get y by itself, I'm going to add over the 1. And so I have -1/8 x squared plus x minus 1 equals y. That's your equation for your parabola, and you're done. Okay? Bring your questions that you have to class. And again, if you want to see an alternate method, you can always scan the QR code and watch Kirk's video. He will show you a different method of how we can get formulas for parabolas. Okay, hope you guys have a great day.